Okay, we're up to review for exam 2 part 5, and we're doing number 9. Okay, so here we want to find where f increases and decreases and find the relative maxes and mins. Alright, so that means we're doing a first derivative test. Okay, so let's start with f of x is equal to x cubed minus 12x squared. And we start by taking the derivative. Alright, so that's 3x squared minus 24x. And let's factor that. Let's pull out a 3x. And we have x minus 3x times x minus 8. Alright, so we're going to put the places where f prime is 0 on the number line to do the plus minus analysis. So f prime is 0 when x is equal to 0 and when x is equal to 8. Here we have no places where f prime does not exist. Alright, so the critical values are only places where f prime is equal to 0. Now do the plus minus analysis. Well, to the right of 8, let's say we choose 9. This is positive. And here let's choose a value between 0 and 8, like 1 for example. This quantity 1 minus 8 is negative, and this is positive, so it's negative here. And if we choose minus 1 to the left of 0, we have negative, negative, so that's positive. Okay, so this means that on the interval to the left of 0, f prime is positive, so f is increasing. And here f prime is negative, that means the function f is decreasing. And here our derivative is positive, so our function is increasing on this interval. Okay, and we see that that 0 must be a maximum, because the function is increasing to the left and decreasing to the right. So this is a max. And 8 must be a min. And if we just find the corresponding y values, substitute into the original to get the maximum point that's on f of x. Okay, so we substitute in 0, and we have 0, 0 here is a relative max. And if we substitute 8, we have 8 cubed minus 12 times 8 squared. Alright, and that's going to be a relative min. And that's at, let's see, just a second. That's at 8 and minus 256. Alright, so let's go on to B. Okay, so here we have f of x is equal to 3x to the 2/3 times x minus 2. Remember I told you that whenever we have a function where, and when we have an exponent that's a fractional exponent, then very often in problems like these we end up with a critical value where f of x does not exist, where f prime does not exist. Alright, so we'll be on the lookout for that. Right, I want to calculate f prime, but I think it's easier for me if I first multiply this out. So let's do that. So I'm going to multiply out 3x to the 2/3 times x, so that's 3x to the 2/3 plus 3/3, that's 5/3. Rather than take the product rule, I think it's easier just to multiply out before we differentiate. Minus 2 times 3 minus 6x to the 2/3. And now we can just differentiate using the product rule. So we have f prime of x is equal to 3 times 5/3 x to the 5/3 minus 3/3, that's x to the 2/3, minus 6 times 2/3 x to the 2/3 minus 3/3, that's minus 1/3. Alright, of course those 3's cancel, and we have 5x to the 2/3 minus, and here 3 goes into 6 twice, so we have a 4 over here, 4x to the minus 1/3. Okay, so you see this negative exponent. If we write this in the denominator, we have a place where we can see that now we have a place where f prime does not exist. F prime does not exist at x equals 0. Okay, since we have two terms, in order to find where f prime is equal to 0, it's really easier if we combine these in a single term, and then we'll set the numerator equal to 0, and that'll be where f prime is equal to 0. So I think it's easier if we do that. The common denominator here is x to the 1/3. So let's do that. So we have here a denominator of x to the 1/3. Let's multiply the top by x to the 1/3. This is 5x to the 2/3 over 1. Now multiply the top by x to the 1/3, and we have 5x to the 2/3 plus 1/3. That's just x to the 1. So here I have a 5x. Okay, so we get 5x minus 4 in the numerator over x to the 1/3. Excuse me. Okay, now we're ready to set the numerator equal to 0. We're getting critical values here. Okay, the numerator is 0 when x is equal to 4/5. That's one critical value. And the denominator is 0 when x equals 0. So those are our critical values. And notice that that f does exist when x equals 0. So x equals 0 is not a vertical asymptote, it is a critical value. Alright, let's do our plus minus analysis of f prime, and we're going to put 0 and 4/5 on the number line. Now notice here I put a closed dot. Even though f prime does not exist at x equals 0, I put a closed dot because f does exist at x equals 0. So this is not a vertical asymptote. So I'd like to write a closed dot over here. Alright, so now let's substitute in a value like 1. Okay, if we put in 1, this is positive and this is positive. Okay, let's put in something between 0 and 4/5, like a half, for example. Alright, so if we do that, this will be negative. It will have 5/2 minus 4. This is negative and this is positive, so we have negative over here. And let's say we put in a minus 1. So this is negative and the denominator is negative. 2 negatives, so this is positive. So here our function f is increasing, here it's decreasing, and here it's increasing, making 0 a max and 4/5 a min. And you can substitute back to get the corresponding, substitute back into f of x, into this function, to get the corresponding y values. For 0, that's easy. The corresponding y value is 0, 0, 0 over here. And you have to use your calculator for this. When you substitute in 4/5, you need to use your calculator. and I got an approximate value for y, which is minus 3.1. Okay. I'm going to make up the exam so that it won't be necessary to use your calculator. Alright, I'm going to try to keep the values pretty simple. Okay, so we're going to stop this video clip over here, and we'll continue in the next one.